So method of mixtures means its formula is net heat loss equal to net heat gain. That means we have taken 2 beakers. In that 2 beakers, what it will contain? It will going to contain some water. The first beaker should be heated up to 90 degrees Celsius and second beaker should be heated up to 60 degrees Celsius. Okay. So what happens, children? Then here already we know heat. What is heat? Heat is energy that flows from a body at a higher temperature to a body at a lower temperature. So what happens here? The heat will flows from 90 degrees Celsius to 60 degrees Celsius. Okay. Okay. Then when it is going to flow to the lower and temperature, so what happens? It's going to lose some heat energy. The net heat loss is equal to net heat gain. When there is a transfer of heat takes place, it is going to lose its heat energy and it is going to gain its heat energy. That means the net heat loss by one body is equals to net heat gain of another body. Yes, so the body which is having higher temperature, it will lose its heat energy. The body which is having lower temperature, it is going to gain some temperature. Okay, so when there is a mixing of these two mixtures, what happens? What happens? They will come to a state of equilibrium. They will come to a state of equilibrium. Yes, so when you mix 90 and 60 degrees Celsius, they will come in between value. That in between value means it is the state of equilibrium. Okay, okay. Okay, now we have took 2 beakers now. One is having 90 degrees Celsius and another one is having 60 degrees Celsius. So both will have same specific heat. The first one will have the heat Q1 and second one will have heat Q2 and its temperature is T1 and its temperature is T2. So we will follow the method of mixtures. So when you follow the method of mixtures, what you have to know that take another container and then what you have to do, you have to mix the both water. So when you are going to mix that water, what temperature it is going to have, we have to know. Yes, the first one is having 90 degrees Celsius and second one is having 60 degrees Celsius. So when you mix both of them, what temperature will be gained in a single container? We have to know that. So to know that, let's do a problem. Already we know specific heat formula. What is specific heat formula? S is equal to Q by M delta T. Yes or no? Yes. So S is equal to Q by M delta T. What we are going to know? We are going to know about heat. How much heat it is going to have. So Q is equal to M into specific heat into change in temperature. Can we write like this? Yes, we can write that. So S equal to Q by M delta T is the formula of specific heat. From this formula, we are going to know about how much heat it is going to have. So to know that, what we have to do, Q is equals to M into S into delta T. Okay, yes. So finally what we want to know, final temperature. Yes, it is having temperature of T1 and it is having temperature of T2. So what could be the final temperature? We are going to find it. Yes, what we are going to find? We are going to find final temperature. Already we are having the values of heat Q1, Q2 and specific heat is same constant value and temperature T1 and T2. initial temperature and second one temperature. So we are going to find the final temperature. Yes, so from specific heat formula we are going to derive it, because we are having here the specific heat formula's values. S equal to Q by M delta T, and Q is equal to M into S into delta T. So where Q1 is equal to Q2, can we write like so? Yes, we can write like so, because when you mix both of them, they both will come to a state of equilibrium. So when they both are going to attain equilibrium, we can write Q1 is equals to Q2. Yes, Q1 is equals to Q2. When Q1 is equal to Q2, what is the value of Q here? The value of Q is M S into delta T. It is Q1 value. It is Q value. It is applied for Q1. Q1 means M1 and delta T means what we have to write. I will say. Just wait. Next. Q2. Q2 means M2 into constant specific heat into change in temperature. So here Q1 equal to Q2. Q1 value is M1 S into delta T equal to M2 S delta T. So what is the delta T value means? M1, here S constant, both are cancelled. So delta T value, what is delta T value means? T1 minus T. We are going to find final temperature value. So we have to write, what we have to do? We have to take first T1. First temperature minus final temperature is equal to M2 into, here delta T means final temperature minus second temperature. So final temperature is T minus T2, second temperature. So here M1 into T1 minus M1 into T is equal to M2 into T minus M2 into T2. Yes. So here, can we write M1 T1 plus, when it comes to this side, this minus will become as a plus M2 T2 is equal to, when this minus comes to this side, what happens? It becomes as a plus 1. M1 T plus M2 T. Then M1 T1 plus M2 T2 is equal to, if you take T as a common, M1 plus M2 into T. Then what we will get? We will get that M1 T1 plus M2 T2 by M1 T1 plus M2 T2 by M1 plus M2. Is equal to T. Yes. So what we found? We found that the formula of final temperature. Yes. So here what happened? First we have taken specific heat formula. S equal to Q by M delta T. So from this, what we have means, it is heat Q1, Q2 and specific heat, they are constant, and first one is having temperature of T1 and second one is having temperature of T2. So now from the specific heat formula we have taken these values, Q equal to M into S into delta T. So where we mix both of them, we get a state of thermal equilibrium. That means Q1 is equal to Q2. So already we are having Q values. So Q, where we have Q values, we can substitute that values into Q1 and Q2. So where Q1 value is m1 into S into delta T. What is the value of delta T? We have to take the first temperature minus final temperature, that is T1 minus T. And here Q2 value, that is m2 into S into delta T. So m2 into S into delta T value, what it is? Final temperature minus second temperature. So here m2 into T minus T2. Here m1 T1 minus m1 T is equal to m2 T minus m2 T2. Then m1 T1, when it comes this side, it becomes positive. m2 T2 is equal to, when it comes this side, it comes a positive value, m1 T plus m2 T. Then m1 T1 plus m2 T2 is equal to, when you take T as a common one, m1 plus m2. So here what equation we can write means, this m1 m2 will be common to the denominator. So let's look here, m1 T1 plus m2 T2 by m1 plus m2 is equal to T. Yes, this is the formula to find out the final temperature. So to find the final temperature here, we will take these values. Okay. What is the value of m1? m1 means here the water is having mass of m1 and this water is having mass of m2. Okay. m1, m2, q1, q2, s and final and initial temperature T1 and T2. Okay. So what is the value of m1 here? Let's take 100. Okay. Just 100 ml of water. Just assume 100 ml of water. So here m1 value is 100 and T1 value is 60 into 90 plus m2 value. That also we will take 100. 100 into T2 value. Let's take 60. Okay. By m1 means we have taken 100 plus m2 means that also 100. That is equal to final temperature T. So 100 into 90 means 9000 plus 100 into 60 means 6000 by 100 plus 100, 200. That is equal to final temperature. So 9000 plus 6000 means how much? 15,000 by 200 is equal to final temperature. If you cancel like so, 2 ones are 2 75s. That means the final temperature T is equal to how much? 75 degree Celsius. So the final temperature how much? It is 75 degrees Celsius. It is in between the value of 90 degrees Celsius and 60 degrees Celsius. So what temperature it is going to have? It is going to have 75 degrees Celsius when you are going to mix 90 degrees Celsius plus 60 degrees Celsius. Then you will get in this between value, no? So we got that between value only. The final temperature of this solution is 75 degrees Celsius. So this is based on the net heat loss is equal to net heat gain. Yes. This is today's class. For more updates, if you like the video, just subscribe to my channel, like, share and comment me down.